اوكي طيب we covered the chapter of IV infusion during the last two lectures. Okay, so just to remind you. Okay. IV infusion شو عبارة عن IV dose that's given in the vein, okay, direct in the vein without a step of absorption. The difference between it and the IV bolus is that the whole dose is not given at once as we do in the IV bolus. Here we give it in a slow infusion rate. And the purpose of that, it's a safer way to do it. And we also talk about the advantages. One of them that we can simply control the concentration depending على the input rate or the infusion rate. This is the main advantage. As second advantage, you can avoid the fluctuations resulting from giving the drug as multiple IV bolus dosing, for example. And we said that we start at 0, then the concentration increase gradually, then we reach what? Steady state, right? For the equation, this is the equation for concentration in plasma. This is for continuous IV infusion, right? As long as the infusion is continuous, we can use this equation before reaching steady state. At steady state, this equation will transform into something like this. So the CVSS is equal to K0 divided by clearance or divided by VD and K. And just I'm doing it, I'm refreshing your memories because we covered all of this before the vacation of Eid. Okay, and we said that definition of the steady state is that the input rate is equal to the what? To the output rate or to the elimination rate. We said that the time that is needed to reach the state is only defined by what? By elimination rate constant or elimination half-life. It's independent from the input rate and the VD and the clearance. All right, it's only dependent on what? The elimination rate constant and elimination half-life. And as we mentioned also, the IV bolus and the IV infusion, they are mirror images from each other, which means that here for IV bolus, the concentration starts at maximum, then decays. For the IV infusion, starts at minimum and then increase to reach what? The maximum, which is the steady state concentration, right? We need one half-life to drop to 50% of CP0, and also we need one half-life to reach 50% of what? And we need two half-lives to reach 75%, right? And three half-lives to reach 87.5%. And 4.32 elimination half-lives to reach 95%, which is equivalent to what? To practical steady state, right? And we said if I increase the input rate, we need this piece of information for today's class today. If I increase the input rate from R to double R, okay, the clearance will not be modified, but the steady state will be what? Will be doubled, and also the concentration at any time point will be doubled, right? If I give an IV infusion for a point and I stop it, what will happen? There will be a decay, right? And if the increase in the concentration is more exponential, the decay also will be mono exponential. That's why if I take 2 points here in the decaying part, I can get the what? Decay, the elimination rate constant and the elimination half-life, right? And also, if I know what's the concentration, this is a mono exponential decay. If I know what's the concentration at B, for example, I can get the concentration at CP1, which is equal to what? The concentration CPB multiplied with the decay factor, right? CP multiplied with 4 minus K for T prime. And T prime is the what? The decay time. This duration of time is the decay time, right? I think we covered problem set till problem set number 10, right? We covered number 10. We talked about loading IV bolus, right? And we said what's the purpose of giving a loading IV bolus? No, this is not why we gave the IV bolus. Why did we give the IV bolus here? The loading IV bolus. How much time do you need to reach steady state? How many half-lives? 4.32 elimination half-lives, right? If the half-life is 100 hours, how many hours are these? 432 hours. If the patient is in emergency condition, can you wait as long as 432 hours till the patient reaches steady state? You cannot, right? Alternatively, what we can do, we give a loading IV bolus. The loading IV bolus purpose is to increase the concentration immediately from 0, okay, to what? To concentration equivalent to CBSS. Now, we said that this is usually not the case, because sometimes the concentration can be higher than CBSS, okay, if the loading dose is higher than needed, or the CP node can be lower than the target CBSS if the loading dose is less than needed, right? The only point, or the only case that we reach steady state immediately is case B, where the loading dose was the exact needed dose. So in that case, CP node was exactly equivalent to the CBSS, so I reached the state immediately, right? وبالتالي I reached the state immediately, then I maintain the steady state by giving the what? The loading IV infusion. And we see in the 3 cases, regardless of the magnitude of the loading IV bolus dose, okay, the steady state is what? Is the same, and is defined by what? Maintaining IV infusion divided by the clearance, right? Okay, and we said that usually when you get more than one input in one example or one question, you divide the inputs into individual graphs, right? And then you solve each one of them separately, and then you what? You combine them by the principle of what? Superposition. Superposition in kinetics is similar to add and subtraction in what? In math, right? So it's equivalent to adding. And if I, for example, want to do the concentration here at 8 hours, simply I need to add CP loading plus CP maintaining, right? I have each of them as a separate input, right? So this is for the maintaining concentration. You know how to get this from the equation of IV infusion, right? Observing that the input rate was delayed, and I did not stop the IV infusion immediately. I had a lag time, so that's why the infusion time is equivalent to T prime. This T prime is the infusion time, not the whole time from time 0, right? And this is the only trick here. For this one, this is our IV bolus. This is something that you are familiar with. You get the concentration here from the what? The IV bolus. Then you add this one to this one, right? And that will give you the total concentration. All this is a summary to what we have taken in the previous 2 classes. Now, let's go to example number 11. Example number 10 is something that you can read by yourself, because it repeats what we have covered in the previous examples. Okay, so example number 10 is a self-reading. Now let's go to example number 11. What's the example number 11? So an anticonvulsant drug was given as a single IV bolus dose at 1 milligram per kilogram, and then after that the drug has been washed out, okay, and then the drug was given again as a constant IV infusion. The same drug concentration are presented in the company table. هلا بديش نفهم هون انه we have given a loading IV bolus dose followed immediately by an IV infusion. We did not do that. The case here, we have given an IV bolus dose. We waited until we have complete wash out of the drug. How many half-lives do we need to have complete wash out? 1.32 elimination half-lives. After the complete wash out of the drug, we have given what? IV infusion. Okay? طبعا with IV, for example, I have given them together. Okay? I can add the inputs, right? By the principle superposition. Because the presence of molecules coming from IV bolus does not affect the pharmacokinetics of drug molecules coming from what? IV infusion, and the opposite, right? The presence of molecules coming from the IV infusion does not modify the pharmacokinetics from what? IV bolus. So simply, if I have given this alone, and then after complete wash out, I then give this one alone. Okay, then I ask you what happens if I combine them together. It's the same thing that we have done here, right? We said that we divide these 2 inputs into 2 graphs, one for each input, right? We solve each input separately, and then at the end, we add them, right? This is the story of the question 11. So again, question 11, the original case is that we did not give a loading IV bolus dose followed immediately by IV infusion. No, What we have given is that we have given an IV bolus dose, waited until complete wash out of the drug, and then we have given the IV infusion. You got it? Okay. طبعا the doses were for the IV bolus 1 milligram per kilogram, and for the IV infusion 0.2 milligram per kilogram per hour. هلا يعني just notice in both cases, whether that's for the IV bolus or the IV infusion, the doses are normalized by what? By body weight, right? In the exam, they did not give us the body weight. So here you have to be very careful with the units, okay? Because all of them will be normalized by what? By kilograms, okay? The first part of it, here, what's the steady state plasma concentration? طبعا من the steady state يجي؟ من IV bolus and IV infusion. IV infusion. What's the steady state for the IV infusion? This is the only information that you have. You know the doses, you know the concentrations. That's it. You don't know the K, you don't know the VD. But you know what's the input rate, which is in this case 0.2 milligram per kilogram per hour. This is the only piece of information that you know. But you don't know the K and the VD. And first you were asked to get the what? The steady state concentration. What's the steady state concentration of the IV infusion? We said that is equal to K0 divided by VD multiplied with K, right? We know the K0. From where to get the VD and the K? We can get them from the IV bolus data, right? So we can use the IV bolus data here to get the K and the VD. And if I change the dosing regimen for the same drug, from an IV bolus to IV infusion, will the values of K and VD change? They will not change, right? Because these values, they are disposition values, right? They shouldn't change by changing the dosing strength or the dosing route or the dosing regimen. So I can use the IV bolus data to get the values of the K and the VD, and then apply them to what? To the IV infusion data. So that's what we have done here. So the CBSS, as we mentioned, is equal to K0 divided by VD multiplied with K. We need to get the K, we need to get the VD. What's the value of the VD? Equal to the dose, 1 milligram per kilogram, divided by what? CP node. What's CP node? From the table it is 10, right? Because it's the concentration measured at 0, right? So this is CP node, so which means that the VD is equal to 0.1. But what are the units? Liters per kilogram, because we have used the dose normalized by kilogram. So now we know the VD. What's the next step to get the K? To get the K, you can use any of these two, any pair of these values. You can use the first with the second, with the third, with the fourth, whatever. Because you have one compartment model, right? The one compartment model, the slope is the same, that will not change. So you can use any 2 points to get the values of the K. So the K is equal to minus natural log of CP2 divided by CP1 divided by T2 minus T1. Okay, I choose to use the last 2 time points. Let me add all. So CP loss is equal to 1.35. اذا انتم شايفين انا بصراحه مش شايف يعني على الاقل على اللوحه داخل بزاويه يمكن هيك اوضح. Still. So CP loss is 1.35. CP the last is 2. They were measured at 10 hours and 8 hours. So simply you can use these values to get the value of the K, which is equivalent to 0.2. Now you know the VD, you know the K. Okay, simply what's CBSS? Is the infusion rate divided by K multiplied with VD, or divided by the clearance, which is equal to the multiplication of K and VD. Right? طيب. ما هو اليوم بلاري بعرفش ليش يعني. أفضل هيك؟ Hopefully. Right. So now we know the K, we know the VD, and this is the first trick in this question, is that you can use the IV bolus data to get the values of PK parameters, and then you can apply them in the IV infusion. Okay, because they will not be modified by the dosing regimen, right? هلا second trick طبعا كل هذا احنا we covered that. أو ممكن نروح لجزء 4 أو D. What's the plasma concentration of the drug 4 hours after stopping the IV infusion? Now the question is only about the IV infusion itself. we have given an IV infusion alone. Okay. We have given an IV infusion. حد وصلنا ل 24 ساعة. تمام. بعد هاي النقطة وقفنا IV infusion. شو بصير التركيز؟ بلش يقل. رايت؟ بس أنا شو التركيز عند 28 ساعة توتال، أو اللي هي المسافة قديش تي برايم؟ هاي المسافة 4 hours. فأنا بدي تركيز هون عند 4 ساعات من نهاية الاي في انفيوجن. رايت؟ حل كيف بنحل؟ بدنا اول شيء التركيز اللي هون صح؟ عند 24 ساعة، طبعا هذا التركيز موجود عندي بالمعطيات ولا لا؟ اللي هو هي 24 ساعة والتركيز عندها قديش؟ 9.9. So I know that the concentration here is equal to كم؟ 9.9. The only thing that I need to do is to multiply this with by what? By decay factor. So let's call this CB2. Okay. CB2 is equal to what? To 9.9 multiply with e power minus k اللي حسبناها قديش طلعت؟ 0.2. right? 0.2 multiply with t prime, which is equal to كم? So that will give you the concentration where? Here, right? Simply. طبعا just something to keep in mind. The question here, all of them are about the same data using the same dosage, right? But what if I ask you a question about a different dose? For example, if I double the dose for IV bolus and ask you what's the concentration at 10 hours, what will be that? Double the concentration is equal to double of 1.35, صح? And if I ask you what's the dose or the concentration after the dose, 2 milligram per kilogram, simply I multiply this by 2. Likewise, for the IV infusion, if I double the IV infusion, okay, and ask you the same question that I asked you here. Okay, so what will be doubled? هاي will be doubled صح؟ هاي راح تكون 9.9 مضروب بكم؟ multiplied with 2, right? So likewise, this one will be 2 multiplied with 9.9 multiplied with the decay factor, صح؟ مظبوط؟ So يعني something that you have to be careful about is the dose. What's the strength of the dose that we are talking about? Is it the original dose that we have measured the concentration from, or is it a different dose? If it is a different dose, simply you do proportionality, right? 1 milligram per kilogram gives you a concentration 1.35. So 2 milligram per kilogram will give you a concentration of double that. 3 milligram per kilogram, we multiply this by 3. And the same applies here. Why? Because we have linear pharmacokinetics, right? In linear pharmacokinetics, okay, everything depends on the dose, right? Right. So part D is something that's new. Part A was something that's new, so we cover only these. Let's go to part F. What's the plasma concentration 4 hours after an IV bolus dose 1 milligram per kilogram followed by a constant IV infusion of 0.1 or 0.2 of 1 milligram per kilogram per hour? Hello, is it this original scenario or it's a different scenario? It's a different scenario. What happened here? We combined them together. In the original scenario, what have we done? We have given an IV bolus dose. We waited until complete washout. Then we have given an IV infusion. Okay. What happens if I combine these together? And what's the concentration at watch time? 4 hours. Right. We know that total concentration is equal to C loading plus C maintaining. صح? The C loading is equal to equivalent to loading dose divided by VD multiplied by E power minus K FT1. Right? We see maintaining K0 divided by clearance multiplied by 1 minus E power minus K FT infusion. Right? Plug in the values. We know the K. Right? We know what's the clearance. Right? We know what's the VD. We know the dose, IV bolus, and the IV infusion. Right? مظبوط? And we know the infusion time. And we know the T. This is one way to do it. Is there a smarter way to do it? What's that? Right. Okay, so I'll go back to the table here. The values at 4 hours are how much? we know at 4 hours here, I know from the same IV bolus dose and the same IV infusion, the concentrations were what? 4.5 and 5.5. So the total is 10, right? This is a smarter way to do it. Now, what if I ask you what would be the total if I double the IV bolus dose and triple the IV infusion rate? So I will double this value and triple this value, صح؟ يعني if I ask what the concentrations from a dose, IV bolus dose خليها 2 ملغ per kilogram, والIV infusion rate خليه 0.6, right? In that case, this will be doubled because this dose is double of the dose, and this will be tripled because the infusion rate was tripled, and then you add them together. Okay? Any questions? Let's go to problem 12. According to the manufacturer, a steady state serum concentration of 17 milligram per liter was measured when the antibiotic cephalosporin was given by IV infusion to 9 adult male volunteers, okay, who have an average body weight of 71.7 kilograms at a rate of 5.3 milligram per kilogram per hour for 4 hours. تمام؟ when the IV infusion was discontinued, the cephalosporin concentration decreased exponentially, declining to 1.5 milligram per liter at 7.5 hours and 7.5 from time 0. Okay, after the start of the IV infusion, calculate the elimination half-life. So شو عملوا هون؟ عطوا loading IV bolus dose حنوصل للسلسلة كان قديش تركيز؟ 17. They stopped the IV infusion at this point, and the concentration started to what? To decay. Then they took a second measurement that was total 6.5 hours from time 0, and they found it to be 1.5 milligram per liter, right? والسؤال هون شو هو؟ What's the value of K and what's the value of elimination half-life? Right? Can you do it? And you have to time for طبعا. اوكي وبعدين تمام
بعدين نحط القانون
اللي هو تبع K is equal to minus natural log تكون هذا non exponential, and this is like you are dealing with IV bolus. This is the CP node and this is some later time point. Okay, just you get the values from those. خليكم معي الشباب اللي ورا. شباب الازرق نايم دور عقد لي ولا 5 نفس الشيء الشباب عشان توزع. شو قيام ليل امبارح؟ Okay, so we said that we have one exponential decay. In that one exponential decay, we know the CP node, or what's equivalent to CP node in IV bolus, and we know another time points. We just get the K from this. Okay. طيب. For question 13, calculate the measure rate constant, or the measure rate عفوا, as listed for a drug given by IV infusion at a rate of 30 milligram per hour. The CSS is 20 milligram per liter. If the rate of infusion was increased to 40 milligram per hour, okay, what will be the new steady state concentration? And also what will be the new elimination rate at steady state. تمام؟ Now we have given home two input rates. واحد منهم 30 ملغ per hour والثاني 40 ملغ per hour. ال 30 نتج عنه steady state concentration قديش؟ 20. هلا أول سؤال I increase the infusion rate from 30 to 40. What will happen to the steady state? Will be the same, or it will increase proportionately? It will increase proportionately, right? قديش راح تصير؟ هسه 30 اعطتنا concentration قديش؟ 20. ال 40 قديش راح تعطينا؟ اوكي؟ سمبلي بضرب 40 في 20 على 30. تطلع قديش؟ 26.7 ملغ بير لتر. تمام؟ هذا اول شيء. طيب الجزء الثاني عند الsteady state, the definition of the steady state is the concentration or the case where but input is equal to the elimination rate, right? elimination rate شو بيساوي elimination rate؟ elimination rate نعرف انه بيساوي clearance مضروب في مين؟ في CP, right? So at steady state elimination rate بيساوي clearance مضروب في CPSS, right? Now if you go, what's CPSS? CPSS is equal to K0 divided by clearance. Now multiply them together. You are multiplying clearance with K divided by clearance. Clearance مع clearance شو بصير فيهم؟ The clearance here will cancel with here, right? مظبوط؟ شو راح يصفي عندك الانبوت ريت بيساوي؟ أو ليش ريت؟ بيساوي input rate. طبعا مرة ثانية this is from the definition يعني we don't need to do these steps. We know from the definition that the input rate is equal to what? To the elimination rate. Okay, where at steady state. تمام؟ معناها آخر لما كان الانبوت ريت بيساوي 30 قديش كان elimination rate at steady state؟ برضه 30 شو اليونتس؟ amount per time, right? طيب لما زدنا الانبوت ريت هلا ل 40 اول شيء شو ترتب عليه؟ steady state شو صار فيها؟ زادت which means ان elimination rate شو راح يصير فيه هون حسب المعادله؟ also elimination rate will increase because elimination rate is proportional لمين؟ ل steady state concentration, which means if I increase the input rate from 30 to 40 the steady state will increase or was increased from 20 to 26.7 and the input rate was increased, so the elimination rate also will be increased to come to 40 because the input rate will be equal to the elimination rate at the new steady state. Right? Any questions? Okay. Now let's talk about the unloading IV infusion. We said that if I am in emergency condition, I cannot wait as long as 4.32 elimination half-lives. I can give what? Loading IV bolus dose. Can I always give a loading IV bolus dose? For example, if you have a drug with narrow therapeutic index, what's loading dose? Loading dose usually a big dose, right? If a drug has a narrow therapeutic index, will you be able to give a loading dose? Because what? It will not be safe, right? You are afraid of toxicity. What's a safer alternative, let's say, than giving a loading IV bolus dose is to give a loading IV infusion. So you are infusing faster. Like, let me ask you this question. If I infuse faster, we have seen this before. If I infuse faster, will I reach the steady state faster? So what's the benefit of giving a loading IV infusion? Right, so for example, if this is the therapeutic window, okay, this is the therapeutic window. Where's the onset of action from dosing regimen اللي هي R? Where's the onset of action? Here, right? What about double R? Where's the input? Where's the onset of action? It's here, right? So you are looking for a faster onset of action, not a faster reaching of the state. The time needed to reach the state in both cases is the same, but you are reaching a different state in case of double R, right? Which is double of that reached from R. Your target is to reach a higher concentration in a shorter period of time. That's why you give a faster input rate. If you give a faster input rate, you will reach a higher concentration in a shorter time. So the onset of action will be what? Faster. Right? طيب هلا you have two inputs in this case. طبعا هون شو السيناريو بيكون؟ You give a loading IV infusion, a faster infusion for a shorter period of time. Okay. Then you what? You stop it. What will happen to that part? It will start to decay. At the same time point where you stop the IV infusion, the first IV infusion, the loading IV infusion, you start maintaining IV infusion. Okay. طبعا again here we have how many inputs? We have two inputs, right? The loading IV infusion and the maintaining IV infusion. One way that you are familiar with is what? Separate them, right? So this is the same scenario. You separate them into a loading IV infusion and then also a maintaining IV infusion. You solve each one of these alone and then what? You add اللي هو أنا مسميهم CB2 مع مين؟ CB3. Can you do this? طبعا here the question is solved in two parts or in two steps, right? First you get the CP1 and then you calculate the CP2 from CP3 because this is a discontinued IV infusion, right? What about the second part? It's a continuous IV infusion, so you use the equation for continuous IV infusion. The only trick here is what? Is that the infusion time is not 30 hours. It's how much? For the second infusion, it's only 10 hours. It's only this period of time, right? Right? So this is the only trick about it. So you have to make sure that you plug in the values of the infusion of T prime. So you equal to 10 hours, right? Not to 30 hours. Because the second infusion did not start at time 0. It started only after a delay of 20 hours. Okay? So I prefer to use this method. Okay? This method is more flexible. Okay, even if I add a third input here. If for example, I added a loading IV bolus and a loading IV infusion and also a continuous IV infusion. You have how many inputs here? 3. You divide them into 3 graphs, right? You solve each graph alone, right? Here you get the CP1, then the CP2 from CP1. Here you get the CP3, and then here you get the CP4. Then at the end of the day, what do you add? What's CP total at 30 hours? It's equal to CP4 plus CP3 plus CP2. If I add another مثلا input, can you do that? Can you do it? Simply you divide it into how many figure, separate graphs with a number of inputs. You solve each graph alone, then you combine them by the principle of superposition. Okay. طيب. وحكينا this method I prefer this method because it's more flexible. Okay. Now let's go to the another method that's here in the slide. This method in the slide it only applies the specific case. What's the specific case? You are given a loading IV infusion for a period of time هو مسميها tau. Then you stop the IV infusion, the first IV infusion. Then you immediately start a second infusion. Okay? There's no gap time between the end of the first infusion and the start of the first infusion. Now in that case, the concentration coming from the loading IV infusion, okay, will be equal to what? It's equal to K0 loading divided by clearance multiplied by e to the power minus K T minus tau plus minus e to multiplied minus e to the power minus K T. Right? What's the T minus tau plus here? This is something new to you, huh? Have you seen this before? What's T minus tau plus? لما كان T 30 وتاو 20 T minus tau قديش؟ Which is a positive value, صح؟ So assume that I'm asking what's the T minus tau and T بتساوي 10. T بتساوي 10 تاو بتساوي 20. قديش T minus tau؟ minus 10. عمركم سمعتوا عن وقت نيجاتيف؟ time cannot be negative, right? cannot have negative. انا حكيت لكم هذا الكورس كله ما فيش شيء نيجاتيف. لا البي كي parameters ولا concentrations ولا time. So time cannot have a negative value. How to solve this issue with this equation, with this generalized equation? By this function. What's T minus tau plus? T minus tau plus is يمكن بسموه خلينا نسميها divided function. هي عبارة عن T minus tau متى؟ لما قبل شوي كانت T أعلى من تاو ولا أقل؟ لما كانت T أعلى من تاو. لما كانت T أعلى من تاو ما كانش عندنا مشكلة. طرحنا 30 ناقص 20 10. You were fine صح؟ طيب. الحالة الثانية طفرنا T بتساوي تاو. قديش الفرق بينهم؟ 0. طب إذا T أقل من تاو يعطيني نيجاتيف. شو بدي اعمل بالحاله هاي؟ بدي احولها لا ما بقدرش احولها بصير راح اعملها 10 بصير اعملها 10. فالخيار الثاني اعملها 0. فهاي راح تصير 0 متى؟ لما تكون t اقل او يساوي تاو. اوكي؟ او ممكن تنكتب بطريقه ثانيه. انا حكيها هون هي عباره عن ايش؟ الماكسيمم t ماينس تاو او بلس او 0 عفوا. يعني متى الزيرو يكون اعلى من t ماينس تاو؟ لما يكون الفرق بينهم شو؟ نيجاتيف. النيجاتيف فاليو اقل من 0 صح؟ بالحاله هاي شو راح ارجع الفانكشن؟ راح ارجع لي 0. طيب اذا كان الفرق بينهم 0 راح ارجع لي 0. طيب اذا الفرق بينهم بوزيتيف راح ارجع لي الفرق زي ما هو. وصلت؟ طيب خلينا نشوف يعني هاي الايكويشن. طبعا هاي او قبل ما نحكي نشوف الايكويشن مشكلتها النهائيه different time points. هاي المعادله لللودنج اي في انفيوجن ومعادله المينتيننج اي في انفيوجن اللي هي تحت راح ارسمها او بولدها بالاخضر. هي هاي عباره عن كي 0 مينتيننج على كليرنس في 1 ماينس يو ماينس كي في ايش؟ تي ماينس تاو بلس. اجين في عندي تي ماينس تاو بلس ونفس الفكره. رايت؟ يعني the rules that apply for t minus tau plus here they also apply لمين؟ فكمان للmaintaining IV infusion. هلا let's take different time points and apply both equations to see how will they يعني simplify at different time points. The first يعني خلينا نحكي more obvious خلينا نحكي scenario when t is larger than tau. Let's say that tau is equal to 20 and t is equal to 30. So I'm talking about this time point here. I think. And the tau is equal to كم حكينا؟ to 20. Now let's take a look at both equations for the loading and the maintaining. First for the loading, K0 loading على clearance في minus K في T minus tau plus. هلا T is equal to قديش؟ to 30. Tau is equal to 20. 30 minus 20 is a positive value صح؟ So it will stay the same. Minus e to power minus K multiplied with T. ليش أحط T هون؟ 30. Right? So this is for the loading IV infusion. What about the maintaining IV infusion? K0 maintaining divided by clearance multiply 1 minus e to power minus K T minus tau. هلا هاي 30 minus 20 10 positive value. ما عندناش مشكله صح؟ طيب خلينا نشوف هلا لما كانت T بتساوي 10 واحد يعمل لي اياها. e to power 0 قديش؟ 1. هاي كلها راح تصير قديش؟ 1 minus e to power minus K في T اللي هي 10. ما عندناش مشكله. فهاي المعادله رجعت لمعادله شو؟ لما تصير 1 minus e to power minus K في T infusion. معادله continuous IV infusion صح؟ طيب هاي بالنسبه للولي. بالنسبه للمينتيننج هاي راح تصير e to power minus K في 0. هذا 0 هذا راح يصير e to power 0 قديش؟ 1 ناقص 1 يعني ايش فيهم خطوه خطوه. هاي راح تصير عباره عن 1 ناقص 1 اللي قديش؟ 0. يعني C مينتين قديش بيكون؟ Does this make sense? At this time point at time equal to 10 hours would يعني the maintaining IV infusion exist? Because the maintaining IV infusion started when? In 20 hours. So there is no contribution coming from the maintaining IV infusion at 10 hours because only the loading IV infusion exists, right? And the loading IV infusion will be treated as continuous IV infusion because at this time point here, okay, at this time point, the loading IV infusion was still what? Continuous. It's not discontinued, right? So that equation will be called, or that part, we call 1 minus e to the power minus k v t, right? Which is the equation of what? Continuous IV infusion, right? So we saw that this equation, or these equations, they work whether the time is less than tau, equal to tau, or larger than tau. But شو المشكلة? What's the problem with this or these equations? They only apply meta when you give a loading IV infusion, you stop it, and then you immediately start. But what about this scenario here? I have given a loading IV infusion. Then I stop it. Okay. At this time point here, this is tau. Okay. I did not start maintaining IV infusion immediately. I waited for an additional 10 hours. So this is tau plus 10. And then at that point, I started maintaining IV infusion. Can you apply this approach here? No, because as I mentioned, we can only apply this approach only when there's no lag time between the end of the first infusion and the beginning of the second infusion. So this scenario can be solved by which method? Right. We divide them into two graphs. Each one will be. أهم شيء طبعا هو التريك وين السكند infusion ما بلش بعد 10 ساعات فعليا، بلش كمان بعد 10 ساعات ثانيين. رايت يعني هون بلش. Okay, second infusion. Maintaining IV infusion did not start immediately. There was an extra 10 hours, right? So هي فكرة الانفيوجن تايم يعني تعمل كوركشن هون هالفاليو هون. اوكي؟ هاي تكون تي يعني اذا هاي هون تي فرضنا بدي التركيز عند 40 ساعة. اوكي؟ هلا الانفيوجن تايم قديش؟ هل هو 20 ساعة راح يكون هاي المسافة كلها؟ ولا هي بس هاي المسافة؟ اللي هي عبارة عن هاي شو راح تصير؟ راح تصير عبارة عن تي ماينس تاو ماينس شو كمان؟ 10. طبعا تاو شو هي؟ تاو هي المسافة هاي بالازرق. رايت؟ فأنا راح أطرح هاي المسافة كلها 40. بدي أطرح منها قديش؟ هاي المسافة 20 وكمان 10. So التريك هي بس موضوع التايم سكيل. اوكي؟ تمام؟ طيب. Let's talk about this example. راح نطبق هون المعادلة اللي حكينا عنها generic equation. اوكي؟ مين يحل لنا السؤال؟ اللي ماسك السلايدات بتطلع فيهم. حل لنا السؤال.
was given as an IV infusion at an infusion rate of 10 milligrams per hour that was stopped after 20 hours. Then the infusion rate was reduced to 5 milligrams per hour and continued at this new infusion rate till steady state was reached.
هلا هاي رسمة أعطينا loading IV infusion تركيز لأنها نزل هذا الكونتينوس لاين والمينتيننج انفيوجن هنا هي هاي داش لاين والمجموع تبعهم at any time point بعد هاي النقطة هو الدوتد لاين هذا يعني هذا الدوتد هو عبارة عن total concentration. اوكي.
What is the drug concentration in milligram per liter 10 hours after reducing the infusion rate 30 hours after starting the IV infusion therapy? أول شيء هو هلا عاطيني الهاف لايف فبقدر أطلع منه الإليمينيشن كونستنت.
طيب.
وعلى القانون عندي يعني تبعت الآي في انفيوجن لودينج آي في انفيوجن يعني هذا بقدر أطلع مباشرة. عندي تي 30.
التايم هو 30 والتاو قديش؟
20.
تاو 20. اوكي هون تي ما عندناش مشكله. طيب هون 30 ناقص 20 ما عندناش مشكله يعني تسوي مباشر بالمعادله هاي. بس هون شو اللي صار؟ اعطينا اي في انفيوجن لودنج على 10 ملي بير اور الانبوت ريت تبعه. بعد 20 ساعه شو عملنا فيه؟ وقفنا بلشنا نيو انفيوجن اللي هو قديش؟ 5 ملي جرام بير اور. رايت؟ حكينا هون لانه طوالي وقفنا هذا وبلشنا الثاني we can apply this relationship. Otherwise, this relationship cannot be applied. طيب. الستيدي ستيت طيب الجزء اللي بعديه. الستيدي ستيت على مين بيعتمد؟ على اللودينج اي في انفيوجن ولا المينتيننج اي في انفيوجن؟ على المينتيننج صح؟ ليش؟ لأن نرجع الرسمة. اللودنج اي في انفيوجن شو بصير بالتركيز تبعه؟ وكمل بقل، والمينتين اي في انفيوجن بضل يستمر لحد ما يوصل لوين؟ يعني هاي لو بدي اكملها الرسمه انا. اللودنج اي في انفيوجن خلينا نرسمها بالاسود، راح يضله نازل وبالاخير eventually راح يوصل لقديش؟ زيرو، رايت؟ او بصير insignificant. واللي جاي من maintaining IV infusion بضل يزيد لحد ما يوصل لوين؟ لا steady state. So the steady state is defined by what? By which infusion? By the maintaining IV infusion. Okay? طيب سؤال للجميع. What happens if I do the opposite? يعني imagine that I started with an IV infusion of 5 milligram per hour. I noticed that the case is not controlled because of low concentrations. I made a decision of increasing the IV infusion from 5 to 10. Okay? How will this question be answered? Again, I started a loading, or let's not call it. هلا الفكرة إنه it's not a loading or يعني high or low. The idea is that one of them is given for a period of time, then discontinued, and the second was started after that time point and continued until we reach what? Steady state. Okay? Let's go back. Now, again, what's the question? I started with an IV infusion of 5 milligram per hour for 20 hours. Then I stopped this 5 milligram per hour infusion, and then I started a new higher infusion rate of 10 milligrams per hour. Okay? What will happen in this case? هل الديفنشن شو كان شرطه الوحيد؟ انه once I stop the first infusion, I need to start the second infusion immediately, right? So simply, خلينا نحط هاي عشان مش راح احطها. هي فعليا هي راح تصير اللودنج IV infusion اللي او discontinued IV infusion is called. And this one will be equal to قديش؟ 10. This is the only change that you will do. What about the steady state concentration in this case? Because now the one that's continuous is not the 5, it's the what? It's the 10. So you replace this 5 by 10. Right? This is the only thing that you need to change. Well, هلا في شغله ثانيه يعني هلا هون we said that we have given a loading IV infusion, then we stop it, and then we started a second infusion. In reality, this is not the case. In reality, what happens, you start by a certain infusion rate, and then you evaluate the concentrations. If they are okay, you will continue. But if they are lower than needed, you will increase the infusion rate. صح? You will increase the infusion rate, or you will reduce the infusion rate if the concentrations are higher than needed, right? So you don't stop a first infusion, then you start the second infusion. Simply, you will change the rate. Whether you increase the rate or you decrease the rate. To simplify it, okay, this is equivalent to stopping the first infusion rate and starting a new infusion rate. Okay? بس يعني هلا مرة ثانية في يعني بالامتحان في the exam the question was this part here. Stopped after 20 hours, then the infusion rate was reduced to 5 milligram per hour. Okay? If I, for example, deleted this part here in blue, then after 20 hours, يعني شلت الجزء هذا حكيت إنه after 20 hours I reduced the infusion rate from 10 to 5. Okay? And this part here is not necessary to say it was stopped. يعني we only tell you this to simplify the case. يعني to make you understand that these are two different inputs. One with a rate of 5 or 10, okay, and the second with a rate of 5. But in reality, we don't do that. We don't stop the IV infusion. We reduce the IV infusion rate from 10 to 5. Okay? Or increase the infusion rate from 5 to 10. تمام؟ وصلت؟ بس يعني the most important thing is that you know when that change was done. We did that change in rate after 20 hours. So which means that the infusion time for the first infusion is how much? 20 hours. and then the second infusion started after 20 hours, right? Okay. Any questions? And the most important يعني خلينا نحكي hint or advice here is that you have to draw the questions. Whether you have given a loading IV bolus dose or you given a loading IV infusion or a combination of them, okay, you have to draw. Or as we said here, or we showed here, like if I give an IV infusion for a certain time, then I stop it, you have to draw, right? To understand what has been exactly asked. To understand what the question is about. لأنه for example مثلا هذا example. If you don't draw, someone else who did not draw may understand that we have given an IV infusion for 4 hours, and then we continued for another 2.5 hours. Then what's the concentration here? That's 1.5 hours. Okay, and you will use a different method to get the what? The K, or the half-life. So it doesn't make sense. No, if I infuse more, the concentration here cannot be 1.5, so it needs to be less than, or it needs to be larger than 17, right? If you infuse for a longer period of time after this state, or practical state, let's say, the concentration will be higher, right? So and this will be a complete miss for the student. The question will be misunderstood that this concentration is here at 1.5, and then rather the student will use this relationship here that we saw before. Okay, and we use this relationship when we have two measurements, one here and one here, and we assume that this is the steady state and this is before steady state. So, does this make sense? No. There's a complete difference, or a whole difference between asking what's the concentration or the half-life. If you know, it's called this CP3, and this is CP1, and this is CP2. Okay? When you know CP3 with CP1, you use a completely different method to get the K if you know CP1 and CP2, right? How will you understand? I'm asking you that you have CP3 or CP2 by drawing. If you draw the question, you understand the question. So most probably, you will solve the question, right? Any questions about IV infusion? And I'll give you a brief introduction about the next chapter. To multiple IV bolus dosing. And before that, let me remind you before, which I explained today at the beginning of the class, is that if you give multiple IV bolus dosing, you will have fluctuations, right? And we said that IV infusion, طبعا كان fluctuation بيعتمد على شو؟ A dose interval, right? The fluctuation depends on the dose interval. The longer the dose interval, the more fluctuation that you'll have. And for example, compare this dose 3 milligram every 24 hours compared to 200 milligrams every 8 hours. Which one has more fluctuation? The one that's given every 24 hours, which is a longer dose interval. So if you have a longer dose interval, you will have more fluctuation. And that's why we said that IV infusion is like you have given a very small doses, okay, at a very short dose intervals, right? That's why you have minimal fluctuation. Got it? And this is my introduction to the next chapter. You have multiple IV bolus dosing where you have fluctuations. Okay, so what's the purpose of giving multiple dosing? Why you don't only give one IV bolus dose and you stop? What happens if I give a loading IV bolus dose? The concentration will decay. What's the duration of period or duration of action in this case? The duration of action will be only this, right? Is this enough? No. Rather, what I can do, I can give multiple IV bolus doses. And there will be what I call accumulation. The concentration will what? Will increase. As long as the drug concentration is within the therapeutic window, you will have a pharmacological action, right? In this case, what's the pharmacological action or the duration of action? Would it be only this time period? Or it will be all of this time period? So which one has longer duration of action? Multiple. So this applies for multiple IV and also applies for multiple oral. The same thing, guys. We are talking about the oral dose. This is an oral dose, for example. The duration of action is only what? This period here. So, which again is not enough, right? To increase the duration of action, what you can do, you can give multiple extravascular doses, and you have in this case the concentration for or within the therapeutic window for a longer period of time, right? So you have a longer duration of action. طبعا ليش بحكي لكم الحكي هلا نروح نشوف ان شاء الله next chapter اللي بعده we will talk about multiple extravascular dosing. So the same principles here they apply also the multiple extravascular. So the fact is that we need to increase the duration of action by giving it the multiple dose, whether that's multiple IV, okay, or multiple extravascular. Right. What are the parameters that you can change? And what are the parameters that you can control in order to change the concentration? حالة الاي في فيوجن البارامتر الوحيد كنا نغيره شو كان؟ مش الدوز كنا نسميه dosing rate او infusion rate صح؟ So in case of IV fusion, the parameter that we changed to control the concentration, okay, was the infusion rate. Here we can change one of two. We can either change the dose or the dose interval. And the ratio between the dose and the dose interval نسميها dosing rate. Okay? So basically we can change the dosing rate. To change the dosing rate, you have one of two options. Either you can change the dose or the dose interval. In case of multiple extravascular, the dosing rate needs to be multiplied by what? By F, right? So to control the cell sequestration, okay, you have one of two options. Either you change the dose or you change the dose interval. Again, this applies also for the extravascular. In both cases, the target is to change the what? The dosing rate. If you need a higher concentration, you will give a higher dosing rate, صح? To reach a higher dosing rate, you have one of two options. Either you increase the dose or reduce the dose interval. And if you reduce the dose interval, you are giving the dose more frequently or less frequently? More frequently, صح? If I increase the dose interval, you are giving less frequently, صح? Again, we'll use the principle of what? Why? Because we have more than one input. يعني كل dose is considered as a different input. Okay? تمام? So we use the principle of superposition. شو شرط principle of superposition؟ ما يأثروا على بعض. شو يعني ما يأثروا على بعض بلغة more professional خلينا نحكي؟ بالpharmacokinetic terms. When do the one input affect or modify the pharmacokinetic from a second input؟ لما يكون في بينهم drug interaction. صح؟ So شرط أساسي هو ما يكون عندي saturation كمان. صح؟ ما يكون عندي drug interaction، ما يكون عندي saturation. وكمان متى ممكن تتغير الفارماكوكاينتيك؟ لما يكون في مثلا ديزيز معين، مثلا هيباتيك ديزيز زي السيروسيس زي هيباتايتس او رينال ديزيز زي مثلا رينال فيلر. شو بيعملوا هدول؟ they can modify the renal clearance or the hepatic clearance. صح؟ يعني clearance is not constant, right? If the clearance is not constant, you don't have linear pharmacokinetic, which means you cannot apply principle of superposition. Okay? So the principle of superposition means that 1 + 1 is equal to come to 2. This is only applicable matter when you have linear pharmacokinetic, when there is no drug-drug interaction, when there is no saturation, when there is no disease state that can modify the drug pharmacokinetics. Right? طيب, what happens here? Usually we give a single dose, okay, whether that's a single IV bolus or a single extravascular. Then from that dose, we learned how to get the PK parameters, right? If you give a single IV bolus dose, you can get the VD and the K, right? If you give a single extravascular dose, you can get the VD over F, you can get the K and the KA. Now, these parameters from a single dose, they are what? Are they dose dependent or dose independent? They are dose independent. If I give multiple doses, these values will be the same, صح? Which means, if I give a single dose, and then I get the parameters from that single dose, I can use these parameters in what? Multiple doses. Because I have linear pharmacokinetics. هلا مبدا السوبربوزيشن بيعتبروه overlay principle. شو يعني overlay principle؟ لو اخذت انا جيت على اخذت هذا الجزء، ما اعرف اذا راح يعطيني بديه ولا لا. بلاش. اخذت هذا الجزء، اوكي، عملت له كات، ماشي، وحطيته فوق هذا الجزء. هاي راح يكونوا متطابقين، راح يكون شكل مختلف. So again, if I cut this part and then overlay it, try and overlay it, I'll put it over this part. Would they be superimposable? شو يعني superimposable؟ يعني متطابقين؟ متطابقين صح؟ شو يعني متطابق بالفارماكوكاينتك؟ What defines the shape in pharmacokinetics? البيك على شو تعتمد؟ على VD صح؟ And the same slope will depends on what? On K. صح؟ هلا we agreed before إنه the values of K and VD from the first dose they apply this to the second, to the third, to the fourth, and the fifth. يعني they are what? They are constant. They are dose number independent. عشان هيك the shapes شو مالهم؟ They are superimposable. If you overlay this part on this part, it will be exactly the same. Right? Why? Because the PK parameters here are the same here for the same drug. وصلت؟ So the principle of superposition is an overlay principle. شو يعني overlay؟ يعني ممكن اجيب هذا البارت واحطه فوقها والاقيهم شو؟ متطابقين. وصلت؟ اوكي. So بكل بساطه مره ثانيه احنا راح نستخدم البيك بارامترز من سنجل دوز ونطبقهم على المالتيبل دوز، بس راح يكون في شويه تويكس، يعني راح نعدل شويه المعادله. يعني معادله السنجل دوز بدها شويه تعديلات. We need some certain modifications the equation for a single dose to be applicable لمين؟ للمالتيبل دوز. اوكي؟ طبعا هذا الحكي كله غطيناه، يعني حكينا we use the principle of superposition which has يعني requirements that we have linear pharmacokinetic. What does it mean to have linear pharmacokinetic? يعني the values of PK parameters they are what? They are dosing number independent, dose strength independent, dosing route حتى independent على الاقل disposition parameters الكي والفيديو والكليرنس والهاف لايف. متى this is not applicable؟ لما يكون عندي saturation او drug drug interaction او pathophysiological conditions that can modify the body pharmacokinetic or the body physiology which modify the drug pharmacokinetic. Okay? طبعا again what's the principle? We have given, for example, this drug is given as an oral dose. We have given the first dose at time 0. An oral dose, right? Then the concentration increases to 21, 22, then decreases again to 19, 16, 14, and so on. High first dose. And this drug is given every 4 hours. The second dose is given at 4 hours here. Okay, the concentration again increase to 21, 22, then decreases. Okay, as we have seen exactly to what? The first dose. هلا هذا اللي جاي من second first dose، هذا جاي من وين؟ second dose. The third dose is given at 8 hours. طبعا دائما remember the first dose نعطيها time قديش؟ 0. So always the first dose is given at time 0. Right? The third dose is given at 8 hours, the fourth dose is given at 12 and so on. هلا لما نيجي مثلا فرضنا عند نقطة معينة، فرضنا عند هاي النقطة. at اللي هي 10 hours. Okay? At 10 hours, what do you have? You have given a third dose, صح؟ But still you have residual drug. يعني شو يعني residual drug؟ يعني remaining drug from the second and the first. What about if I'm talking about this time point here? 20 hours. At 20 hours, you have drug coming from the 5th dose, right? And the remaining drug coming from the 4th, the 3rd, the 2nd, the 1st, right? So always you have this residual drug coming from previous doses. The other thing that you should have noticed is that once you have given the 5th dose, okay, the pharmacokinetic was not modified by presence of molecules coming from the 4th, the 3rd, the 2nd, or 1st, right? Yeah, presence of molecules from previous doses not modify the pharmacokinetic from the last dose. ليش؟ لأنه each one of these doses is behaving independently. ليش؟ لأنه ما في بينهم drug interaction، لأنه ما في بينهم كمان saturation. Okay? So each one of these doses is behaving independently كأنها معطية لحالها. بس بالأخير the total concentration at any time point شو بيساوي؟ يعني مثلا بدنا total هول هي 32.5 مثلا 20 hours. هاي بتساوي هاد بلس هاد بلس هاد وبلس كل هاي التراكيز اللي احنا اعطيناها او كل هاي الدوز اعطيناها، right؟ وصلت الفكره؟ So here we have what we call accumulation. شو يعني accumulation؟ يعني total concentration مثلا عند 20 ساعه مش جاي بس من دوز الخامسه. The total concentration at 20 hours is equal to the concentration coming from the 5th dose in addition to that coming from previous doses. So we have accumulation. Okay? When accumulation happens, for example, if I give a dose 1, then I complete until complete wash out. Then if I give a second dose, will accumulation happen? Because there is a complete wash out of the previous dose. And this is similar to what we have seen in example 11, right, from the chapter of IV infusion. If you wait long enough for complete elimination of dose 1, then IV or the second dose will be given like there's nothing in the body, right? So there will be no accumulation. Compare this to this scenario. You have given the first dose. Before complete elimination, okay, you have given the second dose. So you have residual drug coming from where? The first dose. Then, before a complete elimination of the first and the second, you have given a third dose, and so on. So you will have accumulation here, but you will not have accumulation here. But what defines, you have accumulation or you don't have accumulation? Another way to ask this question, why some drugs in the market, they are given every 4 hours, and others, they are given every 12 hours, and others are given every other day, and others are given maybe every 1 week? What's the difference between half-life, right? The half-life defines the time needed for complete wash out, صح؟ كم half-life بحتاج حتى يصير عندي complete wash out؟ 4.32 تقريبا حتى يصير elimination ل 95%, right? So that depends on the ratio between the dose interval and the half-life. You don't use the dose interval, okay? That's compared to the half-life will not allow complete elimination so that you can have accumulation. وصلت? And that's why some drugs that are given every 1 day, others are given every 4 hours, and so on. Because they are different in the elimination half-life. And can we change the elimination half-life? The half-life is intrinsic criteria. Okay? كيف شخص معين له certain criteria نقدرش نغيرها? The same thing here. The half-life, this is something that's intrinsic. What can we change to change the dosing rate? Dose interval أو حكينا بالبداية هو الدوز, right? So I can change the dose or the dose interval so that I can change the dosing rate. But I cannot change the half-life. I cannot change the VD. I cannot change the clearance, right? بكفي ها؟ طيب. واحد يضوينا الضوء. دي شعبة 2 ولا 5؟ 2 صح. طيب هبة عموش، أسيل عبد المهدي، اللي بحكي اسمه ياخذ قراضه ويطلع. محمد نايف، صهيب توفيق، خالد خرابشة، ولاء قضاء، رهف حامد، أسماء ربابعة، بتول نضال، سارة فايز، ساجدة خلدون، رغد ناصر، غصون عبد الحكيم، أنسان شطناوي، لينا الفاعي، خالد حسن، دنيا حسني، أزهار محمد، سارة السلامين، سارة جمال، خاطري سارة. طيب شيماء أحمد، محمد نبيل، ريهام جهاد، لين محمد، سحر جهاد، ديما أسامة، رنا حازم، لجي نضال، سماح سلامة، سندس لؤي، رشا موفق، رناد علي، لين خليل، شيماء شريف، فيحاء سامي، سهير حاتم، دلال زيدان، لولو حكم، يزن حازم، حمزة محمد، شو اسمك؟ طيب يعطيك العافية.